Welcome to the Joanna Briggs Institute Graduate Research Seminar. I'm Catalin Tufanaru, I'm Research Fellow. This is the topic of my presentation today. Statistics and evidence-based healthcare, the role of statistics, issues and solutions. Well, always when we attend a presentation, we have some expectations. I hope I will meet your expectations. I don't know what you expect, because this is such a general title that maybe you'll have a surprise when I present. I hope that you'll have a surprise, and hopefully we'll have a good discussion after I present my ideas. Okay, so what is the overview of my presentation? I'll briefly say why use statistics in evidence-based healthcare. I will specify some important statistical tools used in evidence-based healthcare. I would like to discuss with you the role of statistics in evidence-based healthcare, what role is for statistics in evidence-based healthcare. Then I'll say that there are some errors and misinterpretations with regard to the essence of statistical approaches and their roles. And please be aware that these are not the usual errors or misinterpretation. For example, what is a p-value, how to interpret the confidence interval. Not the simple errors and usually discussed in the literature, but more fundamental, more essential aspects, and I consider that it is important to discuss these issues. Then I will say something about potential solutions, but you can see that it is question marks, and then we'll have discussions, questions and answers, and as Craig said, that maybe we'll have discussions at the end if I manage to present in 30-40 minutes what I want to say to you. So I would like so if you have questions or commentaries, I would like to discuss all these questions and commentaries at the end of the presentation. Okay, so why use statistics in evidence-based healthcare? I have here quotations from Martin Bland. Martin Bland is a famous professor of statistics from UK, from University of York, and he said that why use statistics in evidence-based healthcare? Because in evidence-based healthcare, most or much of the evidence that we use in evidence-based healthcare is in the form of numerical data. And he stated that statistics is a collection of skills and tools and methods that are useful for the collection, analysis, and evaluation of these numerical data. And therefore, he concluded that statistics is a core or a fundamental aspect of evidence-based practice. I agree with this, and probably you agree with this, that we have much evidence in form of numerical evidence, and indeed, we use statistics in evidence-based healthcare. We need statistics in evidence-based healthcare. Okay, now, I can't cover everything. This is why I said when you attend a presentation, there are some expectations. I will focus on these concepts, important statistical tools or concepts used in evidence-based healthcare. I examined 3 books that are considered very, very important books in evidence-based healthcare. One by Trish Greenhalgh, and this is the most recent edition, How to Read a Paper. It's a famous book in evidence-based healthcare, the 5th edition, How to Read a Paper. Another book is a book published in Australia, Evidence-Based Practice Across Professions or Disciplines. The most recent edition, 2nd edition, and the third one is the famous Users Guides published by American Medical Association in collaboration with Journal of American Medical Association by Gordon Guyatt and others. Gordon Guyatt is the chief editor of the book. This I used the most recent edition of this manual, Users Guides to Evidence-Based Medicine. When I examined these books, I found that important statistical tools for evidence-based healthcare are confidence intervals, statistical tests, these notions of statistical test, type 1 error, type 2 error power, and of course p-values. Now, what I want to discuss with you are not the common error in defining or explaining these concepts, but what I want to discuss with you are the essential characteristics of these tools as proposed by those statisticians who proposed these tools. And I want to do this because I consider that in the current evidence-based healthcare literature, there is a mismatch between what is the true nature or true essence of these statistical tools and what is presented in evidence-based healthcare literature. And I consider that this is a fundamental problem, and I consider that it is important in evidence-based healthcare to apply critical thinking and to examine these concepts, to understand these concepts, and then to conclude if the statistical basis of the current evidence-based healthcare is a solid one, or if we have important problems with the statistical basis of the current evidence-based healthcare practice. And my position from the beginning, I want to say, is that there is a big problem in the current evidence-based healthcare movement with regards the statistical foundations of the evidence-based healthcare practice. Okay. Now, I would like to start with a famous analogy that was proposed by a statistician from Johns Hopkins University, Richard Royal. And in order to understand important aspects in statistics, he said that it is useful to use an analogy with diagnostic medicine and treatment, with the use of diagnostic tests and treatments. And when we have, when we use a test for the diagnostic of a disease, and we observe the results of the test, then three questions are, Richard Royal proposed three questions with regards the results of using diagnostic testing in medicine, and with regard to the ability of treating patients. And he said that these are three questions, and later on in my presentation you will understand why these questions are important, and you'll see how we translate these questions in questions related to the practice of statistics. So first, let's have a look at these questions. So using the diagnostic test, it is possible to see a positive or negative result. The disease is present or the disease is absent in reality. And then these are the questions that Richard Royal proposed. Question one. So observing the results of a diagnostic test, what do I believe now that I have this observation? Do I believe that the patient has the disease? Okay, interesting question. Another question, what should I do now that I have this observation? Should the patient be treated? And this is a very different question. And the third question is, how should I interpret this observation as evidence that the patient has the disease? Is a positive test result evidence that the patient has the disease vis-a-vis of not having the disease? Now, you may wonder how we apply this to statistics, but in a moment. So Richard Royal said that in order to understand different approaches to statistics, it is useful to use these three questions as applied in the field of statistics. And he said, well, when we use a statistical approach, a statistical test, statistical procedures, the same three questions may apply, and these are, what do I believe now that I have this observation in a randomized controlled trial or in an observational study, and we use specific statistical procedures? What should I do now that I have this observation? And the third question is, what does this observation from a randomized trial or observational study, tell me about a statistical hypothesis A versus a statistical hypothesis B, or in other words, how should I interpret this observation as evidence regarding the hypothesis A versus hypothesis B? Now, think about these questions and let's try to discuss when at the end of the presentation, but I would like to know your understanding of statistics and evidence-based healthcare, and try to think about if the procedures, the statistical procedures used currently in evidence-based healthcare answer question 1 or question 2 or question 3. This is a very useful exercise. This is a very useful exercise if we really want to understand the essence of statistics as applied to evidence-based healthcare. Okay, so what do I believe? So when we use statistical procedures in evidence-based healthcare, do we answer the question, what do I believe? What should I do? Or what does this observation tell me about A versus B? So these are 3 questions, and it is important to clarify what type of answer is provided by different statistical procedures in evidence-based healthcare. Now, from my point of view, because I think it's important to disclose my own understanding, I think from my point of view, in ideal conditions, we'll answer question 3. This is what we want, I think, in evidence-based healthcare. This is my understanding. Maybe you disagree, but we'll discuss this. So hopefully, we want an answer to this question. What does this observation tell me about A versus B? Or how should I interpret this observation as evidence regarding one hypothesis versus the other one? So this is my point of view. I don't know what you think about this, but this is my point of view. Okay. Now, I told you that from my point of view, it's important to understand the essence of statistical approaches and their roles with regard to these 3 questions. And I will discuss these 3 important aspects identified in the evidence-based healthcare literature as fundamental. The true essence of confidence intervals, the true essence of statistical tests as proposed by Neyman-Pearson, and the true essence of p-values, but with regard to these 3 questions. So remember that we said that we use this confidence interval, statistical tests, and the p-value, and now the question is, when you use a statistical test or a confidence interval or a p-value, is the answer the answer to question 1, question 2, or question 3? Okay, now, I'll start with confidence intervals, very popular. If you open any book on evidence-based healthcare, you'll see that confidence intervals are proposed, are advocated, are considered a wonderful tool. And in evidence-based healthcare literature, the statement or the claim is that confidence intervals indicate the precision of the results. So I hope that this is what you found in the literature, and this is the common theme, that confidence interval indicate the precision of the results. Now, I said that it's important to understand the essence of these statistical procedures and what kind of answer provide these statistical procedures. Now, so the term precision is used in evidence-based healthcare literature. However, if you check statistical literature, you'll see that there is a mismatch between the use of the term precision in evidence-based healthcare and what is presented as precision, the concept of precision in statistical literature. And I present here a fundamental distinction that is used in statistics that between an initial precision and a final precision. Okay, so what is an initial precision? It's the characteristic of a statistical procedure. When we use a statistical procedure, we expect, before we use the data, how well the procedure will behave in the long run, in use, in the long run. So initial, this is the fundamental idea, that initial precision is an indicator of the characteristics or the properties of a procedure, It's not about the results of using a statistical procedure. And the fundamental statement in statistical literature is that in classical statistics, what we present, and this term is used for use of Fisherian approach, significant testing, p-values, and Neyman Pearson approach, statistical tests, type 1 error, type 2 error, and power. Initial precision is assessed, and you'll see why it is important later. Now, what is final precision? Aims to express the precision of an inference, or in simple words, how close is the estimated sample statistic to the unknown true value of the population parameter. So, final precision refers to the results. How close is the result, what we obtained in reality using real data from a study, to the true value of the parameter? Again, remember that in classical statistics, when we use Fisherian approach or Neyman Pearson approach, final precision is not examined, only initial precision. Now, the question is if it's appropriate to transfer initial precision or the long-term behaviors of a procedure to final precision or to the precision of the estimate. And this is what happened in evidence-based healthcare literature. So in evidence-based healthcare literature, the precision, for example, of a confidence interval, a 95% confidence in the confidence interval, that is an initial precision, this initial precision was transferred as final precision as the precision in the obtained confidence interval. And according to some statisticians, this is completely wrong. Some statisticians will say that because the procedure has this initial precision of 95%, then it is okay to transfer or to attach this final precision to the obtained confidence interval. However, many statisticians will disagree with this. So this is one issue that I want to discuss with you. If it is okay to make this transfer from initial precision of the confidence interval procedure to the final precision. In evidence-based healthcare literature, I couldn't find a discussion about this important distinction between the initial and final precision. If you read the evidence-based healthcare literature, the impression is that the precision that is presented is a final one, that we are sure that we know where we are sure that the values, including the confidence interval, are good values or plausible values for the true value of the parameter. However, this distinction is very important. Okay, now, and there was a serious critique in the evidence, in the statistical literature, with regard to this approach of using or transferring the initial precision that is a characteristic of a procedure or a property of a test to final results of using the test. Okay, now, this is an important point based on what I told you, but it's important to emphasize. When we discuss about confidence intervals from a strict statistical point of view, all initial precision is examined. So we have no final precision according to most of statisticians. Now, this is a very long quote here, but is by a famous statistician from America, Pratt. And he published in 61 a book review. And it's not any book, it's a very, very special book, Testing Statistical Hypotheses by Lehman. Lehman was a professor of statistics at Berkeley, and he, my understanding is that he learned statistics from Jerzy Neyman. Jerzy Neyman invented the new the statistical significant testing, the hypothesis statistical testing, the concept of type 1, type 2 error and power, and confidence interval. And after this discussion of initial and final precision, in this book review, Pratt says very clear that confidence interval were popular among researchers because it was considered that confidence intervals indicate what information is available in the data, but he asked the question, but does confidence interval provide an indication of information that is available? And he said, and he criticized the confidence interval theory because in reality is not an answer, the confidence interval is not an answer to this question, what information is available about the treatment. Okay, now, going back to the three questions proposed by Richard Royal, well, these three questions. What do I believe now that I observe the confidence interval? What should I do? Or what does this observation tell me about statistical hypothesis or versus another one? Or how should I interpret this observation, the confidence interval, as evidence? Think about for a moment, what do you consider in this moment? What do you consider is the correct answer, or what do you think? Confidence interval provide answer to question 1, what do I believe? To question 2, what should I do? Or question 3, what does this observation tell me about one hypothesis versus another one? Okay, now, confidence intervals are advocated and presented as ways to summarize or to present what the data say. Or, in other words, confidence intervals are presented as procedures providing evidence for values of a parameter compared to other values. And the question is, and this question was asked by Royal, if it is valid to interpret confidence intervals as techniques for presenting what the data say, and this is what in evidence-based healthcare literature is presented, that confidence intervals represent techniques for summarizing what the data say, and confidence intervals are presented as tools that provide us evidence that the parameter lies between specific limits. Now, to this question, if the confidence intervals as statistical procedures are examined, the answer to the questions that if it's valid to interpret the confidence intervals as techniques for representing what the data say, the answer is no. Also, I think the most important thing is to go back to Neyman. Jerzy Neyman invented confidence intervals. And he explicitly stated that when we use confidence interval, we cannot conclude that the true value of the unknown parameter is between the observed limits of the confidence interval. We cannot believe this. However, in evidence-based healthcare literature, this is what is presented. That we believe, or based on the confidence interval, we conclude that the true value of the parameter is between the lower limit and the upper limit. This is completely in contradiction with what Jerzy Neyman said. Okay, now, what is interesting is that Neyman presented confidence intervals as procedures to decide what to do, procedures for action. So Neyman never presented confidence intervals as tools to summarize the data, never presented confidence intervals as tools to provide inferential evidence with regard to the unknown value of the parameter. Neyman never advocated or presented or suggested that confidence intervals are indicator of the precision of the data. Never. However, in the current evidence-based healthcare literature, confidence intervals are presented as the ultimate tool in frequently statistics to measure the precision of the results. And this is in contradiction with what Neyman said. Neyman said that these tools are decision tools. Observing the results, observing the lower and the upper limit, we may decide to behave in a way or another way as if we knew that the true value of the parameter was between the computed lower limit and the upper limit. Now, so confidence intervals ask the question, what should I do? According to Neyman, who invented this statistical approach, confidence intervals answer this question. Confidence interval asks this question, what should I do? It is about a decision to act. Now, we continue with hypothesis tests and the three questions in statistics. So, hypothesis tests are very popular, and in evidence-based healthcare literature, you see that hypothesis tests are discussed. The null hypothesis, the alternative, the type 1 error, and the type 1 error and power. Now, the question is, are these hypothesis tests answering the question number 1, what do I believe now that I observe the results of the test? Or are these statistical procedure providing an answer to question 2, what should I do? Or are these statistical procedures providing an answer to question 3, what does this observation tell me about observation hypothesis A versus B? So think about for a moment, and then we'll discuss later. Now, I agree with this point of view that Neyman theory of hypothesis testing refers to second statistical questions, what should I do? It's not what should I believe, it's not what kind of evidence or what evidence I have for a hypothesis versus the other one. And according to Royal, and not only Royal, the Neyman theory of hypothesis testing is not intending to answer the question, what do I believe now, with regards to the effectiveness or harm effects of a treatment now that I observe these results. And also, the Neyman theory of hypothesis testing is not answering the question, how should I interpret the observation as evidence for a hypothesis versus the other one. Now, in the current evidence-based healthcare literature, the hypothesis test or the Neyman theory of hypothesis testing are presented in such a way that the impression is that these tests provide evidence with regards a hypothesis versus the other one. So Neyman theory of hypothesis testing is presented in such a way in the current evidence-based healthcare literature that we are persuaded, or the impression is that we should think of this theory as providing evidence about the effectiveness of a treatment or harmful events or harmful effects of a treatment and so on. However, my point of view, and this is the point that was presented by Royal and others, that in reality, the essence of the Neyman theory of hypothesis testing is not of using these tests to provide statistical evidence for or against a specific hypothesis as advocated in evidence-based healthcare literature, but this theory refers to action, and the theory refers to this second question: what should I do? So what action should I do? What action should I pursue? So the question is that if it's valid to use the Neyman-Pearson's theory and interpret these hypothesis tests as techniques for representing the data, and when we observe the results of statistical tests, of hypothesis tests, is it okay to consider that if we used a Neyman-Pearson test, a hypothesis test with hypothesis and alternative hypothesis, and when we observe the results, is it okay to consider that the data are evidence supporting one hypothesis versus the other? And remember that this is the way that this approach of statistics is recommended, is presented, is advocated in evidence-based healthcare. And according to Royal and others, the answer is no, no. So from a logical point of view, from a statistical point of view, if we really understand the essence of statistical tests as proposed by Neyman and Pearson, we cannot use this test in this way, providing evidence supporting one hypothesis versus the other. Okay. And also, it is important to emphasize again that in Neyman-Pearson, as in all other classical statistics, what is assessed is the initial precision. And for example, if for a test there is a 0.05 probability to reject the one hypothesis, this is a characteristic, this is an initial precision, this is a characteristic of a test. However, when we collected the data and we observe the results, we cannot conclude that the probability of making the error is 0.05. It's not a final precision, it's an initial precision. Okay. Now, if we go back to the original publications by Jerzy Neyman, and this is from a book published in 1950 by Neyman, we understand that tests of statistical hypotheses are used when we have to make a choice between two courses of action, either take step A or take step B. And you see, Neyman presented from the beginning test of statistical hypotheses as decision-making procedures. Neyman never presented statistical hypothesis procedures as procedures providing evidence for one or the other hypothesis, but he presented from the beginning statistical hypothesis procedures as decision-making procedures. And he said, knowing the consequences, positive, negative consequences of different actions, if we consider these consequences, and when we use a statistical hypothesis test, what we want to do is to reduce the error of decisions when we have to take one step or the other one, or when we have to choose between two courses of action. And he presented what he presented. So when he presented that significant test, he used very specific terms and a specific language. And he said that tests are rules for inductive behavior. So he said a test of a statistical hypothesis is a rule of inductive behavior. Now, What is very important to understand, and I think this is missing from current evidence-based care literature, is, and this is this statement, very clear, explicit statement by Neyman, that when we accept a hypothesis, we don't, when we accept a hypothesis, this means only to decide to take an action, A, for example, use this drug or use this intervention, rather than another alternative action. And he emphasized that this does not mean that we necessarily believe that the hypothesis is true. So this is a fundamental point. And also he said, when we reject the hypothesis in this type of test proposed by Neyman, this means only that the rule prescribes action B, use the drug or don't use the drug, and does not imply that we believe that the hypothesis is false. Now, what is strange in the current evidence-based care literature is that the results of statistical hypothesis tests are presented as evidence in favor or against a statistical hypothesis, and then this information is used together with other information to decide an action or a course of action. But in reality, Neyman proposed this from the beginning as a decision procedure, not as providing evidence for or against a statistical hypothesis. And from the beginning, in this decision-making procedure, he introduced the idea of consequences of different actions, consequences of different actions. Now, probably you are familiar with the 2x2 tables presented in statistical books with the true nature of the statistical hypothesis, true or false, and the results of the test, statistically significant or not, and then in the cells you have a 2x2 table, and in the cells you see type 1 error and type 2 error, or the correct decision. Now, however, if we read the original publications by Neyman, we see that his presentation of the 4 options are different from what we find in the current evidence-based care literature. So this is the way he presented the 4 options. A hypothesis is true and an action is taken. You see, in all these presentations, he presents actions. So it is about actions. And this is the original table, and you can't see this table. The table that was proposed by Neyman, you can't see this table in evidence-based care literature. You'll see completely different tables, distorting his message and what he presented. So he said that maybe the null hypothesis is true or the alternative. However, what is important in his approach is that we take an action. We take an action. And then there are different types of errors, and he said that the type 1 and type 2. However, and this is a very important aspect of errors as defined by Neyman. This is the correct approach of what is an error of the first kind of type 1 error. Type 1 error is the error in testing which is considered more important to avoid. This is the correct definition as proposed by Neyman, who invented this concept of errors. And he gave this example that in the problem of testing a drug, the error of the first kind consists in marketing a drug which is dangerously toxic. And the rejection of a non-toxic drug is the error of the second kind. Now, in this approach, as proposed by Neyman, what is considered the hypothesis tested is the hypothesis that is considered in such a way that the rejection of this hypothesis, when in reality is true, is an error of the first kind. You can't see this explanation in evidence-based care literature. You'll find different explanations, And from my point of view, the explanations for type 1 and type 2 error in evidence-based healthcare literature are misleading or distorting the original approach proposed by Neyman. Okay, now, I think I have to, okay, now, and skipping to power, the power was defined by Neyman as the power of detecting the falsehood of the hypothesis tested with respect to an alternative hypothesis. Again, if you read this and if you compare this with what is presented in evidence-based healthcare literature, you'll see that there is a huge gap, mismatch. Now, the last point with regards tests of significant hypothesis testing. In many books, in many articles in evidence-based healthcare literature, you'll see this analogy between diagnostic tests, so using diagnostic tests in medicine with true positive, false positive, and so on, and hypothesis testing. And these four options are presented in the literature: true positive, false positive or type 1 error, false negative, and true negative. We don't have time to discuss now. However, I consider that this is not a valid analogy. It's presented in many publications. Think about what we discussed. Try to read this statistical literature. Understand the essence of hypothesis testing as proposed by Neyman. And from my point of view, it's not a valid analogy. It's completely misleading. Okay, now, the final point is that p-values are very popular in evidence-based healthcare. Now, the question is again, p-values offer an answer to question 1, what do I believe, what should I do, or what does this observation tell me about a hypothesis or another one. Now, the correct approach, and this is a consensus among statisticians, is that a p-value is supposed to indicate the strength of the evidence against the hypothesis that is tested. So, p-values and significant tests, Fisherian test using p-value, answer this third question: how should I interpret these observations as evidence? However, even if we use this, please be aware that p-values were criticized and significant tests were criticized because significant tests and the use of p-values are based on what is called the law of improbability. And many statisticians, not only Richard Royal, they said that this law of improbability is not valid. And if you want to see the arguments why it's not valid, please read the book by Royal. Others rejected this point of view. So there is no consensus if the law of improbability is valid or not. However, I want to emphasize that it's not a strong basis for significant tests, the law of improbability, because it's contested by many statisticians. And also, a famous statistician, William Gossett, who was the statistician at Guinness Brewery in Dublin in 1900, known as student because he signed the articles as student, he sent in a letter to Egon Pearson, the son of Carl Pearson, father of statistics, and co-author with Neyman. He said that even if the p-value is 0.00001, this in itself doesn't in itself necessarily prove that the sample was not drawn randomly from a population, and he emphasized the need for an alternative hypothesis, and he emphasized the idea that the evidence is relative. Okay. And a final point about p-value is that, again, what we measure is initial precision that I indicated before. So initial precision of the procedures. Now, are there solutions for this? And these are with questions marks because I don't tell you that you should apply this or that these are the solutions for the problems that we discussed today. First of all, there is an approach in statistics called the error statistics approach, and this was proposed in the last 40 years by a philosopher of statistics from America, Deborah Mayo. She published a book about error statistics approach and many articles, and she tried to include the Neyman-Pearson approach of hypothesis testing and the use of confidence intervals and p-values in a framework that will justify the use of these statistical procedures in an evidential approach. So her approach was to reject what I said today. So if you are interested in arguments against what I said today, Deborah Mayo probably is the best author for arguments against what I said today. Now, two other approaches that are considered very good approaches providing evidence for evidence-based care are likelihood approach and Bayesian approach. However, there are many debates and discussions, and some statisticians using likelihood approach, they reject the Bayesian approach. Some Bayesians, they reject the likelihood approach, and so on. So there are many debates. This is why I can't say that these are solutions. I'm in the process of understanding this, but probably these three approaches, based on my understanding today, these approaches are better than the approaches I criticized today. And stop.
Thank you.